Hello, everybody. So in this lesson, we're going to cover the independent practice problems for module lesson 15.1, uh, nets and surface area. And we're on page 425 of the 6th grade Go Math textbook. So let's go ahead and get started with number 5. So in the guided practice, we talked about how to take a three-dimensional shape and write it as a two-dimensional representation known as a net. So we have this rectangular cereal box. And if we think of it this way, let's see. Okay, I'm going to say that that's the front. Okay. And then there's a small rectangle next to it. That will be the, I will call that the left side. Okay. So if we fold this, if we cut along here and lay it flat, we'd have a little piece over here that would be the left-hand side, just like this one, right? On the left-hand side. Okay, and then attached to that would be the same rectangle, which would be the back. Okay, so if we cut here and cut here, we can lay it flat out with the left-hand small rectangle in the middle of the two larger rectangles. Okay, and then attached to the front of the box would be the top, right? The top flap of the box. And attached to the front would also be the bottom part. Okay, so what's the only part we're missing here? We have the top, bottom, front, back. Where's the right-hand side? Well, again, if we're laying it flat out, it would be basically right here. Okay. All right, so let's go ahead and write in the dimensions then. So we know that the front is an 8 by 12. So let's just write that like that. And so the back is also the same, which would be 12 by 8. Okay. This skinny rectangle here, that would be the left and the right hand side of the box, is 2 inches wide and 12 inches tall or long. Okay, so 2 by 12. Okay, so these two little pieces are 2 inches long, and this is 12 inches high. Okay, and then the top, going across here, it's going to be 8 inches, and it's 2 inches wide. Okay. All right, so we've written in our dimensions. Now we can figure out the area. So I'm going to say front, back. Okay, so the dimensions of the front and back is 2 times 8 times 12. The top and bottom is 2 times 8 times 2. Okay, because the top and the bottom are exactly the same. So 8 times 2 twice. And then we have the left and right. And the left is 2 by 12. And the right is also 2 by 12. So 2 times 96, 2 times 16, 2 times 24. So 192, 32, 48. Okay. So the front of the box is 96 inches squared. The back is 96 inches squared. The top is 16 inches squared. The bottom is 16 inches squared. The left-hand side is 24 square inches, and the right-hand side is 24 square inches. So add those all up to find the surface area. And we come up with 272 square inches. Okay, I'm sorry, I was just double checking my notes. Okay, so 272 square inches. Okay, and number 6. Inez bought a shipping container at a packaging store. She measured the dimensions shown to the nearest tenth. Sketch a net of the container and label the dimensions. Okay, so we have triangular bases. Okay, so start like that. And then we're going to have 3 rectangles. Okay. So they're telling us the height is 3 inches. The base is 4. This this side is 15 by 3.6. So this side and this side is 15 times 3.6, 15 times 3.6, and 15 times 4. So let's go ahead and find the surface area. So let's say the triangles. There are 2 triangles, right? So 2 times 1/2. The base is 4 and the height is 3. So the triangles equal 2 times 6, which equals 12 inches squared. Okay. Okay, the 3 rectangles. Rectangle 1, I'm going to say 15 times 4, which would give us 60 inches squared. Rectangle 2. Rectangle 2 would be 15 times 3.6. And we also have rectangle 3, which is the same. So rectangles 2 and 3 would be 2 times 15 times 3.6. Okay, 15 times 3.6. 540 square inches. So now we just have to add up those 3 add-ins. So we're going to have 12 plus 60 plus 540. Okay, hold on. This is 3.6. So 54. 3.6 times 15 is 54, and we have to double that. So 2 times 54 is 108. All right. So 108 plus 60 is 168, plus 12 more is 180. So 180 inches squared. Okay. So rectangles 2 and 3 equals 108 inches squared, not 540. See the importance of a decimal point? Okay. All right, number 7. Raj builds a side table in the shape of a cube. Each edge of the cube measures 20 inches. Raj wants to cover the top and 4 sides of the table with ceramic tiles. Each tile has an edge length of 5 inches. How many tiles will he need? Okay, so there's 2 parts here we have to do. First, we have to figure out the surface area of 5 sides of the cube. Okay, he's only going to cover 5 of the sides. And then we have to use the area of each of the tiles to figure out how many tiles we're going to need. So a cube is made up of squares, right? So I really don't even need to draw a net for this one. We're going to have 5 times, okay, 5 square faces. Each of the sides is 20 inches. So 5 times 20 times 20. Okay, 20 by 20 is 1 of the squares. And we have 5 of them. Okay, so if we go 20 times 20, that would be 400. 400 times 5 is 2,000 inches squared. Now each tile is 5 times 5, or 25 square inches. Okay, so how many 25 square inches are in 2,000? So we're just going to divide. So 80 tiles are needed. Okay. Right, number 8. Santana wants to cover a gift box like a rectangular prism with a gift box shaped like a rectangular prism with tinfoil. The foil costs 3 cents per square inch. Santana has the choice between box A, which is 8 inches long, 3 inches wide, and 6 inches high, and box B, which is 10 inches long, 3 inches wide, and 4 inches high. Which box will be less expensive to cover with foil, and by how much? All right. So let's see. I just drawn a quick rough sketch of a rectangular prism. Okay, so they told us that it's 8 inches long, 3 inches wide, 6 inches high. Okay, well, so the front and back right? So the front is 8 times 6 multiplied by 2. The left and right. The right hand side here is 3 times 6, and there's 2 of them. So 2 times 3 times 6. And then we have the top and the bottom. Well, the top and bottom, the bottom here is 8 by 3, so the top is also 8 times 3. Right? So let's figure this out. 2 times 48 is 96. 2 times 18 is 36. And 2 times 24 is 48. So we get 180 inches squared. Okay, now box B. So rather than draw a whole new shape, I'm just going to put the other dimensions underneath it. So the second one is 10 by 3 by 4. All right, so the front and back, in this case, is going to be 2 times. The front is 10 by 4. And the back is also 10 times 4. The left and right. So the right side here, we see that it's still 3 times 4. And there's 2 of those. And then the top and bottom. Well, the bottom is 10 by 3, and there's 2 of them. Okay, so 2 times 40 is 80. 2 times 12 is 24. And 2 times 30 is 60. Okay, now there's 2 ways we could do this. They said that each of the foil costs 3 cents per square inch. And they want to know how much more box A is than box B. So we could do 180 times 0.03 and 165 times 0.03. But couldn't I just subtract the difference between them? This box is 16 square inches more than the second box. So 16 times 3 cents. So 48 cents more. Which box will be less expensive to cover with foil, and by how much? So box B will be less, and it will be 48 cents less. All right. Number 9. Name a 3-dimensional shape that has 4 triangular faces and 1 rectangular face. Well, that's a rectangular pyramid. So we named the shapes based on the base. Okay, since there's only 1 rectangle and the other 4 are triangles, it would be a rectangular pyramid. All right, name a 3-dimensional shape that has 3 rectangular faces and 2 triangular faces. So again, this would be the definition of a prism. Okay, what the book calls a right prism. And so this would be a triangular prism. Okay. Victor wrapped the gift box shown with adhesive paper with no overlaps. How much paper did he use? Okay, so I'm going to go ahead and draw it out on a piece of scratch paper. All right, let's see. So let's deconstruct this box so it's flat. And let's see, let's call this the back. All right. So starting here, this would be the front, right? And then the sides would be left and right. Okay. If those are flat, then we'd have the top here. The bottom would be attached to the front, and then the back would also be attached to the top, right? It's on the back side of this, so it's also attached to the top. All right, so we're writing the dimensions. The front is 8 times 5. The front is 8 times 5. So that's also the back. The bottom is 8 times 6. So 8 times 6 is the bottom and the top. And the left and right are 6 times 5. All right. So top, bottom, we have 2 times 8 times 6. Okay, the bottom is the same as the top. The left and the right would be 2 times 6 times 5. Okay, 6 times 5, and there's the left is also the same. And then we have the front and back of the box, which would be 2 times. The front is 8 times 5. So 2 times 48 is 96 square inches. 2 times 30 is 60 square inches. And 2 times 40 is 80 square inches. Add those up to find the surface area. 236 square inches. Okay. All right, let's look at number 11. Describe how you approach a problem involving surface area. What do you do first? And what are some strategies you can use? So basically, this is asking, what have we been doing? So we first look at the shapes, right? To figure out if it's a prism or a pyramid. And then what are the shapes of the bases and the faces? We've been making a net of those figures, and we've labeled the dimensions. And then we use the right area formulas for each of the faces, and then find the sum of each of the areas. Figure is probably the wrong word to put that. Shape is probably the wrong word. Just to use figure. Okay, so first, is it a prism or a pyramid? That's going to help us decide the shape of the bases and the faces. make a net of the figure. Use the appropriate area formulas. Define the area. And find the sum of the areas. So decide whether the figure is a prism or pyramid. Determine the shape of the bases and faces. Make a net of the figure. Use the appropriate area formulas to find the areas of each of those faces. And then find the sum of the areas. Okay, 12. All right, a pedestal in a craft store is in the shape of a triangular prism. The bases are right triangles with side lengths of 12, 16, and 20 centimeters. The store owner wraps a piece of rectangular cloth around the pedestal, but does not cover the identical bases of the pedestal with cloth. Okay, does not cover. The area of the cloth is 192 square centimeters. So we have a triangular prism. So we know that we have two triangular bases, and we'll have three rectangles. So if the total area, well, let's figure out if we go around just the triangles, right? Okay, because we're not going to use those in our surface area. So perimeter would be 12 plus 16 plus 20. So that would be 48 centimeters. Okay. Okay. Now B, what is the height of the pedestal and how did you find your answer? Okay, so this can be a little confusing, but let's think about it. We have a three-dimensional shape, right? And we, in a sense, if you have like a triangular prism, you could cut that prism into a bunch of different layers of triangles, right? So what we could do is, since we know that the area of the rectangular cloth is 192, we want to know how many 48s, the distance around the triangle, fits in between those two triangles. That's going to tell us the height of the prism. So we can take 192, and divide by 48. Two is 96. 3 is 134. Probably 4. Okay, so the height is 4 centimeters. And 13. Robert sketches two rectangular prisms, A and B. Prisms A side lengths are 5, 6, and 7. Prism B's side lengths were twice those of Prism A's, 10, 12, and 14. Robert says the surface area of Prism B is twice the surface area of prism A. Is he correct? If he is not, how many times as great as prism's A surface area is prism B surface area? Show your work. Okay, so the key here is this phrase right here. Prism B's side lengths were twice those of prism A. So the area is not going to be, surface area is not going to be just twice. Each dimension is twice. So let's see. 5 times 6 for prism A. Okay, we're going to have two sides that are 5 times 6. We're going to have two sides that are 6 times 7. And we're going to have two sides that are 5 times 7. Okay. 5 times 6, 6 times 7, and 5 times 7. Okay. So 2 times 30 is 60. 2 times 42 is 84. And 2 times 35 is 70. So prism A equals 214. Prism B is going to be 2 times 10 times 12. 2 times 12 times 14. And 2 times 10 times 14. Okay, so 2 times 120 is 240. 14 times 12, 168. So that's 168 plus 168, 336. And 2 times 140 is 280. Okay, add these up. 6, 15, 8. All right, so if it was twice, it would be 428. It's not 428. So let's divide 856 by 214. That'll tell me how many times greater this number is than this. I know it's not 2. Actually, I think it's going to be like 4. Yeah. So it is actually 4 times prism A's surface area. And now it makes sense, right? Because look at here. Let's just look at the 5 times 6. Okay. 5 times 6, if that's just area, that would be 30, right? Well, they doubled that shape in the bottom to go 10 by 12. Well, that was 120. Well, 30 times 44 is 120. So we could have gotten it just by just using one of the faces, actually. Okay. All right, so that's it for our discussion of nets and surface area. So until next time, I will see you soon.